Hello, class. I'm here to talk about problem 23. Probably is gonna be a long video, so I suggest that if you do not have a lot of time to follow the steps right now, that you try to watch at a time that you have more chance to follow everything. The reason is because this problem, we're going to learn how to set up the objective function that is not given to you. We're going to learn how to uh, put together all the constraints for this problem. From there, we're going to have to calculate each constraint to find our corner points so we can graph it, find the feasible region and the optimal solution according to the graph. And then I'm also going to be showing you how you learn which constraints are binding and what do they mean by that. So it's quite a few steps that are going to have to be followed, and I really need you to pay attention. Okay, so I have put it the problem here. Actually, I have cut it because once I set all the objective function, whether whether I'm being asked to maximize or minimize that function and all the constraints, I am gonna delete all this here so we have more room to work. Also, if you notice right here, you're missing some columns, and the reason for that is because I have already set up everything where we are gonna be able to use solver to confirm our results. So let's get started. So problem 23 is talking about motorcycles. Okay, so this is really showing if you have a real life example, how would you put all this together in formulas to the point where you can actually find to you can optimize all these values and provide an optimal solution, a actual solution for your manager or for the company. So right here, Embassy Motorcycles manufactures two lightweight motorcycles designed for easy handling and safety. So we know they're talking about two different motorcycles. Uh, Please remember that we always work uh, with X and Y, A and B, X1, X2, or even more variables. Right here, we are going to be presented with the Easy Rider model, and we're going to be presented with the Lady Sport model. So we could actually use these letters to as our variables. So let's continue. The Easy Rider model has a new engine. Okay, so the Easy Rider, so let's put it over here so you know what we're talking about. Okay, and then the Lady Sport. And then I'm gonna put it like this. Okay, here you go. Uh, the Easy Rider model has a new engine and low profile that make it easy to balance. The Lady Sport model is slightly larger, which uses a more traditional engine and is specifically designed to appeal to women riders. Embassy produces the engines for both models at its Des Moines, Iowa plant. I'm not sure if you say Des Moines. I said it how I understand. Okay, right there, we're just defining that we have two different types of motorcycles, correct? So the best way, well, we could call it A and B, or we could call it X and Y. But since we have Easy Rider and Lady Sport, we can also call it E and L. So our variables are gonna be E and L. Okay. Let's continue. Each Easy Rider engine requires 6 hours of manufacturing time, and each Lady Sport engine requires 3 hours of manufacturing time. and the company has 2,100 hours of engine manufacturing time available for the next production period. So it's telling you right here that in hours, to produce this engine, it takes 6 hours of manufacturing. To produce this engine, it takes 3 hours of manufacturing. But the total hours they have is 2,100 hours. So right here, you have your first constraint. So let's try to put that in a formula right here, or maybe over here. So they're saying we have 6 hours of manufacturing time for Easy Rider, and then we have 3 hours for the Lady Sport engine manufacturing time, correct? And this cannot be higher, it actually has to be less or equal than 2,100 because that's the maximum they have. Okay, so let's close here, 2,100. That's our first constraint right here. Actually, I can even move. I have to stop saying actually, right? I notice I say that a lot. Sorry about that. I'm trying to move it here. Uh, so we can label then. And then so you remember. So the first constraint, right, or we can say C1 is manufacturing time. Manufacturing time. Okay. Okay, let's keep going. So we got rid of this part right here, which I'm going to delete, and I'm going to move this up. And these are the questions. So now we also got this part, and now it says, Embassy's motorcycle frame supplier can supply as many easy rider frames as needed. So there's no constraint, there's no limit for the frames for the Easy Rider. However, the Lady Sport frame is more complex and the supplier can only provide up to 280 Lady Sport frames for the next production period. So there it is, our second constraint. So our second constraint is going to be production, frame production, right? So it says right here for the Easy Rider there is no limit. However, for the Lady Sport model, they only can provide up to 280 frames. Up to, therefore, no more than 280. And we're talking about frame production. You don't have to label then. I just find it that once you're trying to read the graph and analyze your binding constraints, it makes it easier to identify which one is what. Your third constraint, or should I keep reading actually? Sorry about that. Uh, right there. Final assembling and testing requires 2 hours for each Easy Rider model and 2.5 hours for each Lady Sport model. A maximum of 1,000 hours of assembly and testing time are available for the next production period. Therefore, right here is your third constraint, which assembly and testing time, correct? Again, I'm talking assembly and testing time, so I'm talking hours. It's saying that it takes 2 hours for each Easy Rider, and it takes 2.5 hours for each Lady Sport, and a maximum of 1,000 hours of assembly and test time are available for the next production period. So no more than 1,000 hours. So less or equals to 1,000 hours. Let's keep reading to see if we have any more constraints or anything else that we need here. The company's accounting department projects a profit contribution of 2,400 for each Easy Rider produced and 1,800 for each Lady Sport produced. So right there, they're projecting a profit, right? So they're trying to maximize their profit, and they are telling that they expect for each Easy Rider 2400 and for each Lady Sport produce 1800. Therefore, our objective function is going to be you're trying to maximize 2400 for the Easy Rider plus, I'm going to fix that, 1800 for the Lady Sport. Let me, I'm not select the whole table because I don't want to open the other columns here yet. There we go. So now let me move this up here and I'm gonna move this down here. Actually, I'm gonna get rid of this as well. Okay, let me do that. So now we have completed all uh, the variables I need for this problem. Okay, let's go over here and let's just, you don't have, another thing that I've been meaning to mention, you are not required to follow my processes. I show you different processes, different ways, but I always use Excel, which is my preferred software. I find it easy to work in Excel. You may disagree and use something different, which is fine with me, as long again you provide all your calculations so I can see how you got to the results. If you remember, if you watch problem 3, I did very basic. I actually insert line by line, and then I show you how to put this shaded area. On problem 11, I did a little more, and I was able to develop the graph faster, and I also present you with solver, and then I added one by one over here. In problem 23, which we have gone through all that, I plan to do a more advanced graph, or because in the end it's easier, and also on solver I'm gonna show you some shortcuts so you don't have to do one by one. Okay, so here you go. So it says a, formulate a linear programming model that can be used to determine the number of units of each model that should be produced in order to maximize the total contribution to profit. Well, we finished right here. This is A. Okay, we are done with A. Now solve the problem graphically and find the optimal solution. And lastly, we're going to do the constraints they are binding. So let me just move this away for now and I'll bring it back. Okay, so now for B is asking us to graph all this. If you do remember from problem 3 and problem 11, the way I did it, I said, I repeated the formula, set the left side of the equation to 0, solve for the right side. Then I set the right side to 0, and then I solve for the left side, so forth and so on. So now what I'm just going to do, a little different, like I said, since we have gone through the basics. For constraint 1, which is your manufacturing time, okay, you're gonna have so many hours for the Easy Ride and for the Lady Sport. So let's just look at constraint 1, the first one right here. If I set this side over here, the equation, to 0, which I'm gonna make it like this. So right now, if I set, actually, yeah, that's okay. If I set this side to 0, Lady Sport is gonna be what? You're gonna have to do 3L equals, let me do it over here, equals 2100, correct? And then you divide both sides by 3, therefore you're gonna have 700 over here. Okay, now we're gonna no fill, and we're gonna uh, set this one to 0. So 3 times 0 is 0, so I don't need that. So now we have 6. I'm going to continue on this side. We're going to have 6L, oh, 6E, sorry about that, equals to 2100. Therefore, you divide both sides by 6. You're gonna get divided by 6. You're gonna get 350. Therefore, when you set this, the right side to 0, you get 350. So these are your 2 points for constraint, first constraint. Okay. So let's continue that same path, and I'm gonna repeat here because I'm gonna do one for constraint 2, and I'm gonna do one for constraint 3. Okay. And I can delete this. So now, really, if you take a look here, I would set this value to 0, correct? And solve for this value. Well, really, it's already telling you that L is equals to 280. Therefore, here is 280. Now, if we would set this value to 0, we wouldn't have anything because we would be dividing by 0. Therefore, both would be 0. Okay. For the third constraint, we're gonna do set this value to 0. So we're gonna do 2.5 L is equals 1,000, and L is equals 1,000 divided by 2.5. So when E is 0, L is 400. And now we're gonna do the other side. We're gonna set this to 0 because 2.5 times 0 is 0, right? And then we're gonna do 2E plus, actually equals, because the second part is 0, 1,000. Therefore, E is equals, divide both by 2. Wait, helps if I put as an equation. Therefore, when L is 0, then E is 500. Okay. Now that we have these constraints, which I'm going to move then all the way down here, just want you to see it better, which is letter B, correct? I'm trying to see. Actually, I want to move then over here. And I want to move then over here. Well, I cannot make it this smaller because of this labels right here. But that's fine. As long as you can see the values, I want you to just see this value, the points. So your points here are going to be 350 for E, 700 for L, 0 for E, 280 for L, and 500 for E, and 400 for L. Okay. And as far, and so I'm going to delete this so you know where that came from. And now we're going to do the graph. One thing that I want you to note is that I'm going to be putting E, which the left side of my equation would be my X, and right here would be my Y. So remember, the E is going to be on my horizontal line, and my L is going to be on my vertical line, which because they're equivalent to X and Y. Okay, so let's go ahead and insert the graph. Okay, we're gonna go over here. I'm gonna put the graph about here. We're gonna go over here and we're gonna just insert a frame for the graph. It's easier, and then now you can go and select the data you want. So let's add, your series name is gonna be your constraint 1, and the X values, remember the left side of the equation. So these are X values, and your Y values are over here, the right side of the equation, right here, right? I shouldn't say the left and right because of solver. I'm saying it's still on the left side, the left and right side for the left side of the equation. Please don't get all confused with the left and right. One thing is the left hand side, and the other thing is the right hand side. And I'm here, I'm just saying left side and right side of the left side. Okay, so let's do OK. And you're going to notice our first line of our graph, okay, which right here 0700, and right here 350 and 0. For the second line, now we're gonna stay here, select the data, we're gonna add, and your series name is gonna be your constraint 2, okay, and your x values. Do you see how it says right here, x values? So your x values are on this side right here, and your y values are on this side over here. So you do it okay, and here we go. Well, if you only have a value for lady sports, that's why in your easy rider is 0, therefore is only gonna show on the vertical axis. Okay. Now let's go ahead and add the last constraint. So your last constraint is constraint 3, and your x values are over here, and your y values are over here. And oops, make sure it selects. I did that before. And when you select correct, it actually tell you what is gonna show. And see how I did incorrect? This first one is supposed to show 0 and 500. There, that's how you confirm that you have the correct value. Do OK, and then do OK. You could go ahead and include the 00 for the orange, but really you don't need it because actually right here you have a point that is gonna come from here. So just do OK, and here's your graph. So now let's go ahead and look for the feasible region. One thing that if you're maximizing this objective function, you're looking for the point, the furthest point from your origin. Okay, so your furthest point, it's about here. So if you would just try to um, eyeball it, you're gonna see that it's about 200. And if you go down here, it's about, I would say, 250. Yeah, it seems to be right in the middle. I would say that your optimal value would be about 200, 250. But again, graphs are never exact. So unless you calculate, evaluate each constraint, you cannot confirm that. If I had nothing else and they told me, what do you think? I'll say, well, I believe that my optimal value would be about produce 200 of the um, Easy Rider and 250 on my or 200 of my Lady Sports and 250 or my Easy Rider. Sorry about that. This is Easy Rider right here. I actually want to see if I can add some labels. The labels, it should be there actually. Mm, I think it's over here, right? Okay, you could label. We can label that. Okay, data labels. Data labels is just pointing exactly the values that are there. The arrow, here go the legend, that's what I want. So you can see down here which constraints what. And on axis, so you remember which one is what, you can just say this is Easy Rider, wait, Easy Rider, correct? And this is Lady Sport. This way you won't forget this is the E and this is the L. So now let's go ahead and shade the feasible region. Sorry, I just sneezed. I gonna insert a free form right here, and I'm gonna start at 0. I don't think it's really doing what I want. Oh, here we go. You gotta see the cross. If you don't see this little cross, that means it didn't work. Just click the right button on the 0, 0 point. See where it says 0, 0? Then drag it all the way over here. This is your maximum over here to be on your feasible region. If you go higher than that, it's not valid because you're passing that point. Okay, and then we're gonna go uh, over here, about here I would say. We're gonna go also to this other point over here, and then to this point over here, and lastly we're gonna go over here. There we go. And you have now defined your feasible region. Everything else out of this region, it's not valid. Remember, you're maximizing, therefore, or actually you're maximizing, but right here, so the furthest you go on your feasible region, the better, but right here it's telling you that all the values have to be less or equal than their points. Here we go. That's your feasible region. By looking at it again, the point that seems to go the furthest is this one over here. Well, when the problem asks about binding constraints, it means the constraints that are crossing in order for you to get the furthest point on your graph. Well, the constraints that are crossing right here are 1. If you click on it, see how it highlights? And the other one that is crossing right here is 3. So just by looking at this, you could say that the constraints that are binding, that means if you change their values, it will change your optimal solution. And on this one right here, it's not part of my optimal point, which I'm gonna calculate, and you're gonna see that it is right here, but I wanna know how much. Okay, we kind of figure it's over here, but we need to know how much. So now that we have looked at here and defined that constraints 1 and 3 are binding because they cross right at the optimal solution, these are the two equations that are binding. Therefore, I'm going to simplify then to get a value for E and a value for L. So how I'm going to do that, I'm going to repeat the equations right here. Instead of repeating, let me just copy them over here and then copy this one over here. Okay, and now I'm gonna try to make all this smaller. I'm gonna simplify it in a way to get a value for uh, E and a value for L, which are gonna be my optimal solution values. Well, how can I simplify? There are several ways. You can isolate, for example, you can solve it for E and isolate the L on the right side, and here same thing. Or you can multiply one equation, and this is algebra, by a negative sign. For example, if here is 6, I could multiply this second equation by -3, because -3 times 2e is -6e, and then I would eliminate e from the equation and only work with L. So once I find L, then I can have the value for E. The other way that you could do uh, that, it really doesn't matter whichever you choose that is best for you. Sides by -6e, so I can eliminate this first one right here. So I'm gonna do 3L is equals to 2100 minus 6e. So now you gotta divide both sides by 3. So I have L is equals to 2100 divided by 3 minus 2e, and that's my equation, where I can now go back and substitute on my second one and then go back and plug in here. Okay, this is the second equation. I'm gonna do 2e plus 2.5L is equals 1000, correct? So now I can go ahead and replace L for these values right here so I can define E. So 2E plus 2.5 times, I'm going to put it here, 700 minus 2E. Wait, I got these values from over here where L is equals to, so I'm multiplying 2.5 times these values. Okay, and then I'm doing like this so you can see it first, equals 1,000, correct? So now we're gonna do that 2E, I keep putting 3, um, 2E plus, then you're gonna do 2.5 times 700, and if you prefer you can do like this to make sure you're on the right tracks, correct? Minus 2.5 times 2E, it's 5E. You following me? Let me put it like this, equals 2.5 times 2, it's 5. But see how you have the E over here? So 2.5 times 2E is minus 5E equals 1,000. Well, now we have 2E minus 5E is 3E, right? And then now we're going to subtract this 1750 from both sides. So 1,000 minus the 1750 is minus, oh, see, I made a mistake here because 2E minus 5E is minus 3E. That's important. So now you multiply both sides by a negative, and you're going to have that E is equals to 750 divided by 3. However, you need to put as an equation. It's 250. So now you have found right here, which I'm going to actually change, that E is equals to 50. Well, if E is equals to 50, let's go back here and we do that L is equals to 700 minus 2 times 250, and we have that L is equals to 100. And if you remember, I said that it seems right here that my L it's about 200, so over here, and that my E is about 250 and is right on. So our optimal solution should be 200 and 250, or you can say E 250 and L 200. And if you go back to your maximum, to your max objective function, which is 2400 times 250 plus 1800 times the 200. So let's do that. 2400 times 250 plus 1800 times 200. This means there's not enough space. All you need to do is to move here, and you have a value of $960,000. Therefore, if you have calculated all the other constraints, if you have plugged these values, you're going to learn that this is your actual optimal solution, and this is how many they should produce to make $960,000. So let me recap. All I did was I first set up all the constraints because they start with the constraints. Then I set up the objective function. Once I had all that, I I solve for L, solve for E on this equation first to get these values, these points. Then I did the second constraint and got these points. Then I did the third constraint and got these points. I went to my graph and I add one by one and I got my points. Once I got my points, I drew my feasible region, and by looking here, it seems that my point that will provide the maximum uh, amount it's going to be right here. Therefore, if you look, this is constraint 1 over here, and this is constraint 3. Therefore, I'm saying that the constraint bindings to form this value would be constraints 1 and 3. Therefore, I have simplified then, and I have found the values for E and L at their optimal solution, which is this point right here, which you could go ahead if you want and insert a text box right here, and you could put that your optimal solution is equals to uh, 250 and 200. Your E first and then your L, this point over here, or you can just put, you don't have to, I'm just showing you. And now that we have done all that, we're gonna look at solver, okay, which is what I have put. Go ahead and delete this, which I have set up over here, and I'm gonna delete all this, so please bear with me. Let me do it up, and then I'm gonna move all this over here. So, and I'm gonna explain it, because now we're gonna be using solver to give you exactly these values and this amount right here without having to do all this. In this case, you have to, because the problem is asking you to solve the problem graphically. But if I would only ask you the values, you could use solver. So what does this mean right here? Well, remember I have the Easy Rider E and Lady Sport L, which I have put in here, and I want to know how many of them should I produce to make the maximum amount in dollars. So right here, if you remember, they had $2,400 for Easy Rider to produce, and 18 for each, and 1,800 for Lady Sports. And the formula that I put it over here equals 2,400 times E, which is this cell right here, B, cell column B, cell 9. Okay, so when we find this value, it's gonna multiply by 2,400, and for the latest port plus the latest port 1,800 times L, therefore column B, cell right here, row 10, is gonna be how many for my latest port. So 1,800 times how many shows up here is gonna give me the maximum value. And right here on this side, which I can move down, I have put my constraints, which I can even put a C1, and then constraint 1, constraint 2, and then constraint 3. Okay. So now remember that I said these values are set. You cannot change. They are bound to this. Therefore, your right hand side, which I have mentioned before, and here's your left hand side. However, the left hand side means the whole equation of the left hand side. So let's make it like this. And here's your equality sign. So right here, these values are set. You cannot change this. However, over here, you have to insert formulas to reflect these equations. So for the first one, it says that you have to have 6 hours of Easy Rider plus 3 hours of Lady Sports. This is what I did in here. It's going to be 6 hours times as many Easy Riders plus 3 times as many Lady Sports. For the second constraint, we only have Lady Sport equals 280, correct? Therefore, it's just going to be exactly the value that shows in Lady Sport right here. The solver gives to us. And last, we're going to have 2E plus 2.5L equals 1,000. So I have put that 2 times E, which is Easy Rider, plus 2.5 times Lady Sports. 2E plus 2.5L. This is what is over here. Equals 1,000. Okay, now, and we know that they all have to be less or equals. Therefore, we have everything for our solver. I can leave this over here because solver, when I click the OK button, is gonna give you the values. It should give you here 250 for Easy Rider, 200 for Lady Sport, in a total of 960,000 if we're correct. If something shows different, then we have to see what is wrong. Now that you have installed Solver, all you need to go is to go to Data, Solver, which I have put it before, and I'm gonna show you now. Instead of adding one by one, I'm just deleting all this, since all these constraints, they're all the same type, they all have to be less or equal, I'm going to show you how you can do that faster. So let's set your objective. Your objective is right here. You want to know how much money, and you want to maximize that value, correct? And you're going to change, which I did this before. I'm changing the cells, easy writing lady sports. So solver has to figure right here, work with these values to give me the maximum value. My constraints we're going to add. Again, like I said, since these all have the same equality size, what you could do is select all three for the left hand side, and they all have to be less or equal to the equivalent, the respective right hand side. And then you do OK. Another thing you could have put in here is that E and L, they have to be higher or equals than 0. Um, but right here also we have them all constrained, unconstrained variables no negative. So it should work just fine. And again, we're going to be always using simplex LP. So now let's click solve and hope that this change over here to the point where it shows 250 for the Easy Rider, 200 for the Lady Sport, in a total of 960,000. If not, then we need to see what is wrong. Do solve, and it's gonna give you this message, and here you go, 250, 200, 960,000. Solver found a solution. All constraints and optimality conditions are satisfied. And then if you want, you can go ahead and click here so I can show you uh, uh, an additional thing for your constraints, for your binding constraints. Do OK, and it's going to generate some reports. On your limit reports, is showing 250 for E, 200 for L, and here's your value, and here has calculated individually. On your sensitivity report, if we look at the shadow price, if a shadow price shows 0, every time a shadow price, and see, these are your constraints, that's why I labeled them, because then on your report is going to come exactly how you label them. That's the good thing. On your shadow price, if you notice a value of 0, that's a non-binding constraint. If shows you any other values, that means those are binding constraints. And if you notice right here, as we have determined before, constraint 1 and constraint 3, they are binding. That means if we do modify these values, everything else is going to modify. Not for this one here, and it tells you how much you actually could increase as much as you want and only allow a 80 decrease without modifying your optimal solution. So as we have answered before, then for we solve, we know the optimal solution. And the last, you're going to answer that the constraints binding are either constraint 1 and 3, or you can say manufacturing and the assembly and testing time are binding, or whatever you prefer. And that would be the end of problem 23.